No, put it on that one. I'm going to be waiting. Just put it out. We're 11, we're almost at 12 pounds, so we should have the majority of our refrigerant. So we're just waiting here to get down. We're at 3 psi. We're almost there. Now at the same time, get this out. Feel this time. So why is it so hot? No, it's not boiling. Why is it so hot? No. Why is the recovery tank so hot? Why is the tank we are recovering into so hot? Okay. The refrigerant going into the recovery tank is coming from where? It's coming from the recovery machine, right? Right. So inside, so bring the other recovery machine, the one that's open. So this is the inside of our recovery machine, right? So we have two things here. We have what? Three things: motor, compressor, the compressor here, and then these coils in the front. No, it's what? That's your condenser coil. So we're not just compressing. So you have a compressor increasing the pressure, making it a high pressure vapor, but then you have a condenser. So what's going into the tank? The condensed refrigerant. So what type of refrigerant is going into the tank? No, it's 410A, of course, but what type? How would you describe it? There's a condenser right here. Coming in as a vapor? No, as a liquid. As a liquid. What kind of liquid? As a high pressure liquid. Correct. So we're taking. So okay, what are we taking out of here? Liquid. Well, no, we were taking some liquid, but we're taking low pressure refrigerant, right? And then our recovery machine turns it into what? It's a high pressure. If it's a vapor, it does what with the vapor? It condenses it. So what's going into the tank? High pressure liquid. So if I take a temperature reading on my tank, the tank is 104 degrees right now. This one is 90 degrees, but that's only because we have that our heating blanket on it. It's almost, so we can't go by the scale. We have to go by the pressure. We have to go by the pressure inside the tank. Zero. So it's saying 0, but remember what it's both sides are 0, right? Okay. This is why we have to check. So if I go in there, so hold up your gauge. Okay, close both those out. Close both out. No, come here. There's refrigerant still inside the tank. It is not going to stay at 0, even if it's a tiny, tiny amount. There's refrigerant in that tank. Not much. Okay, so that could mean we have the majority of the refrigerant out of our tank. Oh, look. You see? It just went up a tiny, tiny, like 1 psi. You see that? Yeah. That means what? So there's still refrigerant inside the tank. So what do we have to do? We got to open it up and keep what? We got to keep recovering. That's what people don't get. Because according to the EPA, depending on the refrigerant, I think 410A, I forgot if it's 0 psi or 10 inches. I know it's one or the other, but if it doesn't stay at that low setting, it's still refrigerant. We'll figure it out. Okay, so I'm at 4 inches, 5 inches. Okay, so we're gonna wrap this up in a second. Now, let's say if I'm comfortable with the vacuum inside my machine, right? I want to try to remove as much refrigerant as possible from the lines. So even if my machine is in a good state, so I'm going to close my tank first. Now, understand, we're just moving refrigerant from one tank to the next, but this could be our system. The machine that we're about to go to, we're going to do this same thing with that system, right? So now I'm running my recovery machine with the valves on the machine closed because I want to pull all the refrigerant out of this line, then out of this line. Then I'm going to close the suction on my recovery machine. So you can see here, this is saying my lines are like 10 inches. So the majority should be there. So I'm closing the suction first. Okay. Then I'm closing my discharge. Closing the tank, excuse me. Then I'm closing my discharge. Then I'm shutting down. Now, here's the thing. This is why I always like to use the shortest hose over here between the tank and the recovery machine. This thing is filled with liquid refrigerant. All right. As a matter of fact, I'm going to try and get some of that liquid out of here, right? Okay. So let's see how much liquid. As a matter of fact, let me put this. I want people to see exactly what I mean with liquid refrigerant. So if you recall what we were just looking at, the evaporation that was taking place. Let me see. So people
Well, what we were looking at earlier, we saw the evaporation causing that condensation and frost. Well, if you're not careful, you can get that taking place in your skin. So, okay. I just want to get my camera on here.
That could burn your skin, right? Like it's equivalent to like a burn.
It'll absolutely burn your skin. Okay. 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 So just twist. Okay. Open it. Yeah. Get it. All right. Move your hand. Move your hand. More. Okay. So that's not too bad. So that's not too bad. If it was a lot of refrigerant, the same way we saw that frost up on the gauge manifold and on the hoses, that would have been frosted around here. Yes, that's not too bad. But that's why I always recover from the discharge of the machine. I go to the vapor side, because if you go to the liquid side, this whole hose is going to be filled with liquid. And then once you disconnect, then everything is coming out. Okay. All right. So let's get a vacuum pump. So we're going to put a vacuum pump on there and evacuate it. Yeah. Yeah. Just have to evacuate the tank. Oh, yeah. Yep. Yeah. Yes, sir. So what'll happen is we'll get it running, and then as it's running, we'll come get the yeah. Yeah. No, I'm doing everything. Yeah. Yes. Well, we're not just going to do by weight, we're going to do by super heat as well. So yeah, we're going to do it. Yeah, it's gonna work. It's gonna work. Yeah. No, we're actually. So remember the last job that we did and we broadcasted. We're on YouTube right now. I'll send you the link. Yeah, I like people to see, because the issue is people don't. Unfortunately, people don't trust service people anymore, and we need to. Well, that's what we had to change that.
Right, because all they do is lie to you. I don't trust any service people.
Yeah.
You know, I do all this stuff myself here, as you know, but it's difficult to trust service people because they lie to you all the time. Even if you need to replace a contactor, they tell you that the compressor is bad. You know, it's true.
Yeah.
It is true.
Well, that's where what we're doing, we want to train, like you're a property manager, but you know this stuff, a lot of this stuff yourself. So you can protect, your tenants and your company from being taken advantage of. And that's where I'm trying to get more property managers to learn this stuff. Not that they're going to do the work. The majority of these guys will never pick up a wrench, but just to understand
the knowledge.
Exactly. That's literally what I'm doing, trying to educate people about this stuff, because for me, the bad part, you know how to do it. So set that up. The bad part about it is we're not protecting the environment, because all these laws that they keep talking about, change all this equipment and do all this stuff, it's supposed to be about protecting the environment. So if people are not aware that somebody might, like this job we're doing today, somebody's saying, hey, I'm going to change out this compressor. How many times have you seen people do the water jar thing where they're bleeding the refrigerant through a bucket of water or something? And, you know, that's bad for not just the environment, but you know what R22 costs right now. So if I got to buy new R22 and charge that to the customer, it's bad for everybody. And I'm trying to educate people about this.
Yeah. Well, the R22 that they have is not new refrigerant. It's recovered refrigerant.
Yeah.
I don't have new refrigerant R22.
That's fine.
I have recovered.
Yeah, that's fine. We got filter dryers and everything.
Maybe there is enough in the system as well. I don't know.
Well, I'm wondering, because you said something about the pressure that's on that unit, you know, currently, because I think you said something like 170 PSI with the machine not running. For R22, that's crazy.
It's 170 and 150.
No, that's bad. No, for R22, that sounds a little high for a standing pressure. So
standings. No, running.
Yes, but if there's no differential, then it's still the same as standing. So
exactly. When you shut it off, it doesn't move much either.
Exactly. So if that's the case, then that's telling us that maybe the machine might be overcharged. It could be. Maybe that's maybe because it wouldn't be a high pressure cutout that would stop it from running, but you never know.
Well, if the valves, if there is a high pressure cutout on it,
yes,
because I tested it. But if the valves of the compressor are bad, then the high pressure cutout is not going to kick in because you're not going to reach the 300s.
Yes.
So if the valves are bad, it's going to keep pumping with whatever pressure there is inside and it stays the same.
Yes.
So let's see, maybe you have enough refrigerant to charge it.
Yeah, I mean, it'll run. It'll run.
Yeah.
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 Yep.
Maybe you will have enough refrigerant to charge it. Let me know.
Yes, sir.
Let me know.
Yes, sir. All right, man.
You take care of them because I really, I mean, these are family for me.
Well, this is, we have to reinstill trust, with this industry. That's the biggest thing that we have to reinstill trust, especially, I'm going to be very interested. Like you said, it's a scientific facility. So people really don't even understand how important HVAC is for scientific purposes. So,
of course. Yeah, they do research in there. I mean, they're always researching. So, I mean, they're not, I mean, those people, they survive off for research. That's what they survive off, because otherwise they don't make money. People don't send samples into the labs and they charge people to test samples. It's not like that. It's not like that. They only do research. So
no, we'll take care of them.
Always very tight with money.
Yep, we'll take care of them. All right, buddy. All right. Yes, sir. So we're evacuating. That's fine. Because you got to understand something. It's going to take a minute. We're at 27 inches. It's not going to be until it gets down to 29 inches that you're going to see microns. All right. So there we go, right there. This is what I mean. People have to practice their craft. They have to know what is the difference between inches of mercury and microns, and why do we need to go down to microns. Now, before we go too far, what I want to do actually, so I'm going to shut all this off. I want to spritz a little nitrogen, and we're going to blow out. Shut all this down. Okay. So take that off of here. So we're going to spritz in some nitrogen.
You don't want me.
So we're over here printing out letters for our students. So.
Oh yeah, fire department gave me my confirmation for my test.
Gave you what?
Give me
Confirmation.
my confirmation, the date that I sent in a week ago. Yeah, they got me up for the 18th. They locked
For the
me in. 12 o'clock. In there.
July? Of August. What's the date they gave you for the practical?
The 18th, July 18th at 12 o'clock.
July
And yesterday
Okay.
they confirmed me.
Okay, so we got 2.5 weeks. We gotta do what we gotta do.
Yeah, definitely. I'm gonna go hard, even harder. I
So
feel
show me-
comfortable though.
Show me how you put nitrogen in. So let's put, we only need like 200 PSI. Now, the reason why we're putting nitrogen in here, we want to blow out any oil inside of here, because that's the biggest problem. People don't understand, it's not just about mixing the refrigerants. If there's any residual oil inside of this tank, most of your 410As, those types of refrigerant. So is your tank open? Okay, so we're looking at our nitrogen tank here. So we got about 500 PSI inside of this tank, so it's not that much. We're gonna need a new tank for this system. And over there, that's the regulator side. Okay, now over here, this is saying that our tank is in a vacuum. So I'm opening up, actually my tank valves are open. So if I open here, so this is gonna be the liquid side. Now, what I'm gonna do here, I'm going to, okay, flip the tank over, please. Close the vapor valve on the tank. Close both valves. Close both. Now, disconnect the vapor. Now, what I'm doing is any oil that's inside of here should drain all the way down to the bottom, which is where that vapor valve is at. Okay, now open up the liquid. Now, look at what happens when I open up that liquid. Is this open? Oh, sorry. There we go. So see that? Okay, now open up the vapor over here. Yeah, you see that? Whoa, you see that?
Yes.
What do you think?
That's the oil.
There we go. You saw that, Phil? Okay. All right. Okay, so now we're gonna evacuate. You saw that spray, Phil?
Sorry, I was muted. Yes, I did. I seen it.
Yes. Again, this is, people don't understand, we can't, service companies, they can't buy new tanks for every job that they're gonna go on. That's impossible. So what you have to be able to do is find ways to clean out your equipment in between the different jobs. Now we'll put it back onto the vapor side. We have to have ways of cleaning out our equipment in between jobs to reuse it.
How many guys actually don't do this on the field?
Listen, a lot of people don't even recover refrigerant, so.
Yeah, that's what you were saying before, like so much problems with the ozone with it. Problems.
Yeah.
They're not doing it right.
Okay. So we got, now, hold on, before we, disconnect that.
Oh,
So this is the pressure inside of our tank. We're at 150 PSI. Okay, so disconnect there.
everything's filled here. This is open.
Well, we need to bleed out the nitrogen.
Okay.
So as soon as you disconnect. There we go. So we need to get our machine down to atmospheric pressure before we hook it back up to our vacuum pump. So all that pressure, you can smell the oil, right? Refrigerant has no odor. So if I'm smelling something, that's an indication of all the oil residue being removed from here. Now we're gonna put this into a vacuum so that when we go to our job, no, don't worry about it. Oh,
Ready to pull it.
that's just coming out of there. So you can see as that pressure's going down. Let's grab another nitro tank. So we can use that regulator, but we need a new tank.
Okay.
So I can get this set up. So the pressure is so high, it's actually pushing against the fitting.
Wow.
So I can't start this. Well, I could, if I turn on the vacuum pump with any pressure in there, it could mess up the seals inside the vacuum pump. So we definitely don't want to do that. Leaving all that out. Okay, so now I'm at atmospheric pressure. Tighten this up here. Turn this on. Open all my valves. See my oil level. So we got a new tank of nitrogen for the job we're about to do. You can see that smoke. That smoke is from any moisture inside of the unit. It's being evaporated because of the high temperature of my vacuum pump. It's not that bad, but after a while, your vacuum pump will get really, really hot. Okay, remember what I said? Once we get down to 29 inches, we should start seeing microns on our micron gauge. There we go. So now we're in microns. Okay, so we're gonna let that run. So Geraldo over here is switching over our regulator from one nitrogen tank to the next. There we go.
Yeah, I need to come down there, get some hands on, man.
Yep.
Yeah, soon, man. I've been so busy lately. It's ridiculous.
Okay. So that's the male flare that goes into the tank.
I want to do it like hand tight, like you said, like you taught me.
Okay. Now, what we're going to use that for, we're actually going to, because our recovery machine was just using 410A, so we actually have to clean out our recovery machine too.
Yeah.
Okay, so I just want to spritz a little nitrogen through my
Let me adjust my gauge.
recovery machine. You don't want to over tighten it. Don't over-tighten it.
I'm just adjusting my gauge.
Okay. So guys, with the gauge, with your regulator, you want to make sure as you tighten it on that the gauges are facing in a position that you can see it. Because sometimes people will have it facing down and you can't actually measure the pressure inside. Always be careful when you're putting your hoses on. You don't want to strip the threads. Hold that for a second, please. Because if we strip our threads, it's going to be difficult for us to put the hose on something else. Okay. Now again, I'm putting nitrogen in here so that I can, oh snap, so we're missing a
Okay.
O-ring.
Not a tape that.
Okay, so we got our O-rings here. Now, people ask sometimes, why do we have an angled and a straight connector
Yes.
here for our lines? So if you look here, if I'm trying to put this on there, because this is straight, it's difficult and I may not have room. So that's why you have the angled connection, just to make it a little bit easier. You know what? This is 5/16. So 1/4 inch flare, nail flare. So that's not gonna fit. So we'll try this one. This is why it's so important to understand all your equipment.
I put it at the edge.
No, it's fine. So what happens, sometimes your threads get a little matted. Okay, so check over here. Now, if I open up my tank, boom. So I have 2000 PSI inside of here. And then the pressure, I open here that I want to send through there. So right now that is about 200 PSI. So there's 200 PSI sitting inside of here. So look right down here. Look down here. No, the camera.
Yes.
The camera.
Thank you.
Okay.
Focus there. Okay.
Okay, so just trying to push out any oil inside of there. Okay, now, over here, so check this out. I'm in a vacuum. So my tank is at 600 microns. So while I'm here, I can evacuate my tank as well. That's fine. No, look over here. Okay, so my vacuum pump is running. Closing that, I'm gonna take from this side. Close here. So I'm taking from this side, connecting here, so I can evacuate my machine. Okay, so now I'm evacuating my machine as well, right? Make sure my discharge is closed. No. So I'm just cleaning out any impurities inside of my recovery machine.
Thank you.
Right, so all we're doing, I want to make sure as I go to this R22 job, there is no trace whatsoever of 410A inside my recovery machine. So everything we're using here,
We need to clean up.
everything we're using here, our recovery tank, our gauge manifold, micron gauge, vacuum pump, recovery machine. Now it's safe for us to take onto an R22 job. And now I don't have to worry about any cross contamination. Okay, so let's get a bucket, and we're gonna see which tools we're gonna be taking. So it's always a good idea to test all your equipment, so we know what hoses are missing, things like O-rings. We know what tanks of 410A, nitrogen are good. We're gonna put a label onto our tank. So we know this is R22 only. So just put a tag or something on there. Okay, so let's get our ProPress. Let's get our all our fittings. We're going to need. So the job that we're going on today, guys, we always like to avoid brazing if we can. But if we need to braze, we have a swage tool, so we don't have to use any couplings, and that reduces our brazing. Our ProPress, our our, just in case we need it, our settling. Okay, signing letters over here. Very nice, torch that. Okay, make sure we got the new one. So make sure we got our heads. So with our Pro Press, we have different type heads. We have the, plumbing heads, and then we have AC heads. These are the plumbing heads. Okay. Yeah, so that would have been very bad.
No?
Oh, no, I'm sorry. These are the AC heads. Okay, so yeah, we just need the tool. So bring the plumbing one too, so we can compare the different sizes. So 1/4 inch, 3/8 inch, 1/2 inch, 5/8 inch, 1/4, and then 7/8. So it's missing the one. So they're interesting. They don't have 1 inch. Okay, good enough. So where the fittings at? Oh, here we go. So the way these work is we have the fittings that go inside the jaw, and the jaw opens and it squeezes it to create a leak tight seal. So I would say for modern jobs, this is becoming more and more of a necessity. Okay, cool. So this is the tool itself. These are the plumbing fittings. So you can see here, this is.
You don't need this.
No. Those are the ones we need. So this kit came with the plumbing fittings, but we ordered the heads for the ACR separately. Those are our tool, our batteries, our charger. Okay. Okay, we're gonna need some pipe. So, all right, so I'll show you what we're gonna be doing here in a second.
Yeah, I'm gonna have to cut out now, boss. I'll talk to you guys soon. I gotta shoot back.
So this is the compressor that we're gonna be using. Okay. So it looks like we might have to do a little bit of. Okay, so it's interesting because I looked up the model Whoa. Whoa. Holy smoke. Oh my goodness. Oh my goodness. This is interesting. So looking here. So this unit does not come with a piece of equipment called a crankcase heater. The crankcase heater is what heats up this unit when the compressor is off in order to keep the refrigerant out of the oil. Oh, that's not good. Right? We got to do what we got to do. Okay. Oh boy. All right. So this is actually a 3/8 inch line. So it's a good thing that we're looking at this because I was looking up the model number on the. I was looking up the model number online, and it was saying that it had 3/4 and 1/2 inch line. So we have interesting because we have a 3/8 connection here. I think that's definitely not 3/4. I think that's probably like either 1/2 inch or 5/8 inch. And this is like 1/2 inch. So I'm wondering about this. So we got fittings. What do we got here? So we got some elbows. So it's not showing our refrigerant line sizes on here. Interesting. So that was nitrogen that they had inside of the unit. Okay, so let's see how we're gonna do this. That's a 1/2 inch. Yeah, that's too small. This is 5/8 inch. Okay, so you know what? So this is 3/4. So we're gonna need 3/4 line. So it's a good thing we have our brazing plus our ProPress. We're gonna need 3/4 to come out here. Then we can go see how we need to go inside of the unit. We're definitely gonna have to braze these, and then we can press the rest. So okay, cool. All right, so we will pick this up later. We're gonna pick this